Hello, today we're going to be doing LeetCode question 42. It's called Trapping Rainwater, and it's a hard level question. So I'll read the description here. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. And so our example here, it gives us this elevation map where each block is, I guess, a meter squared. And this is the height map, 0, 1, 0. So 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. And basically, when we want to compute how much water it can trap after raining, we're going to infer that it's rained a lot, so none of these will be half full. I'm going to be doing two approaches to this question today. The memo and 2 pointers. The memo has a time complexity of O(n) and space complexity of O(n), and 2 pointers solution has a time complexity of also O(n), but a better space complexity of O(1). So I'll start off with the memo. So I'm just going to define a n just to help me in the long run. I don't want to type that a lot. My left max is equal to a list, and when I do this basically just creates a list. So if my heights list has like 0, 1, 3, 1, 4 values, left max would be equal to 0, 0, 0, 0. It just takes the length of n and multiplies it. And I'll be doing the same thing with right max later. And we need a temporary, or I guess I shouldn't call it temporary, but that's just the variable name. For I in range n, so I'm going to loop this n times. I first have to get the larger one. Temp is equal to the max of temp and height I. So basically what I'm saying here, I want to change temp to the larger one because I'm looking for the max. And temp, so say if I was on 3 right now, and I'm looking, my previous largest one is 2, and my height I is 3, so temp is now equal to 3. And then I change my left max I. Left max I is equal to temp. And this I part, it just means like, so I'll give another example. Height is equal to 0, 1, 3, 0. How about this one? 1, 0, 3, 1. And basically, so if I've already, right now my temp, it should be 1, and I'm on this one. So now temp is 3. Left max I, I'm on 3 here, so the third index, left max is equal to this one, right? So this one should be changed to 1, and this one should be changed to 3. And then we're going to do the same thing for right. You'll see it's pretty similar. There's like probably one part I think that's different. And it's right here. It's right here. The reason I'm doing this, first I'll type it out. The reason I have 3 values and it's n minus 1 is because this is a reverse for loop. And this -1 tells Python that I want it to loop in reverse. So from the last element in the list, from this one to the 0 here, which is n minus 1. The reason I put n minus 1 is because in Python, the value you're ending with is not included. So I wanted to put n minus 1 so it won't include that, but will include n. Because if I put n, it won't include it. So then it's the same thing. Temp is equal to the larger one of temp, or my current one. Height I, and then my right max I is equal to temp. And then here, we're going to calculate the amount of water I can trap. And so here, we're just taking, here, I'll put it first. cannot. Okay, so here I'm adding this to the area. So I want the smaller one of left max or right max on my current one and my height I. So say I'm calculating this one, this spot, this one. I want to take the smaller one, which right now at the moment is left max, because if I were to choose right max for this one, the water would flow out. So I want to choose the smaller one. But right now it seems that this is holding 1, but if I ignored this part, it actually returned 2 blocks of water, even though it's only holding 1. So I have to take away the amount of solid that's actually in my spot right now. So actually 1. So it can only hold 1 block of water. And then of course we return area. And one more thing, you might be thinking, why are they both I? Wouldn't it be the same value? No, because remember, we put a reverse loop. So the first value in right max is actually the last value in this one. Okay, it's accepted. Let's try submitting. And you'll see here, actually I got pretty lucky. I got 60 milliseconds runtime and 14.9 megabytes of memory. This was another solution that was written the same way, and this is about the average of 84 milliseconds. Actually, I've only submitted it once, but these other ones, this like ridiculously high one is the brute force. The time complexity is really bad, ON squared, but I'm not going to touch on that because these are, in my opinion, easier to code and faster. And so now I'm going to move on to 2 pointers. So 2 pointers is, well, I think we've reviewed it in past videos, like in question 11. So it's like binary search, but not binary search. So what I mean by that is, I still have a left and right, so I'm starting from the 1 and 0 and coming in, but I don't have a midpoint. So I'm not comparing the midpoint to anything. We still have left max and right max, but they're integers, not lists. So it's still a constant amount of memory because they're not lists. While I'm at it, I'll define area. And so basically, while left is smaller than or equal to right, I'll keep looping. So first I'm checking if my height left is larger than my left max. So I'm basically checking if my current value is larger than what is supposedly my largest left value. If it is, I'm going to change it. Left max is equal to height left. Same thing with the right. Whoa, okay. Must have hit J key a little too much. Oh my god, I screwed up the indentation. Okay, so there it is. And then it's the same thing basically with the area. But I'm just checking here. So if my left max is the larger one, then I'll just use right max, because I want, as I explained earlier, I can't use this 3 because it'll spill out. So it's right max minus my height I. Oh no, it's not height I. It's the height of right. And then, of course, the else area and equals to left max minus height left. And the reason here that I'm using not I and right, I actually forgot to do this. I'm first using right because I'm starting from this side and going in and calculating the area as I go, and I'm taking away 1, so I'm kind of just moving down the line until they meet. return area and run code. Check for any errors. Alright, accepted. Let's try and submit it. And you'll see here, this one's 56 milliseconds. It's the same memory because it's honestly not that noticeable, but if you have really large test cases, it will be noticeable. And so actually here, it wasn't that much slower than our memo, but normally it's usually like 84 milliseconds versus 52. So then you can really see it's honestly just a little faster, just in general. That's all I have today. Thank you. Goodbye.